Everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 6 minus 64 equals to 0, and we will solve this problem for the values of n. So here we find all the roots of n. So these roots are real or imaginary. I can find all these roots. So the very first thing we are going to do is, here first we rewrite this equation as here you have n to the power of 6, and we will write it as n squared and its whole cubed, minus here you have 64 and we write it as 4 cubed, and this whole equation equals to 0. So in the next step we will use here the nice cubic formula, and you know about this formula. If we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So in the next step we will just apply this formula on the left hand side, and its left hand side will becomes in the form of n squared minus 4 times of n squared and its whole squared plus 4 times of n squared and plus 4 squared. So now we will use here the nice formula, and it is equals to 0. So here you have two cases. The first case is we take n square minus 4 equals to 0, and the other case is we take this n square and its whole square plus 4 times of n square plus here you have square of 4 is 16 equals to 0. So here we have these two cases. Now first I can name this as equation number 1 and this as equation number 2. So now we will solve these two cases one by one. So now first we will focus on the case number 1. So in case number 1 we have n squared minus 4 equals to 0, and we will rewrite this equation as n squared minus 2 squared equals to 0, and now we can apply here the nice algebraic formula, and you know about this one. If we have a squared minus b squared, it is equals to a minus b times of a plus b. So now we can apply here this nice formula on the left hand side of the above term, and its left hand side will becomes n minus 2 times of n plus 2, and this whole equation equals to 0. So here we have again two cases. The first is we take n minus 2 equals to 0, and the second is we take n plus 2 equals to 0. So here you will get the first two real roots are plus 2 and minus 2. So these are the first two real roots of this equation. And now we move our case number 2. So in case number 2 we will just first write here equation number 2 becomes. So our equation number 2 will be looks like in the form of n square and its whole square plus 4 times of n square plus 16 equals to 0. So now first I can change this nice equation into the quadratic form, so that in order to convert this into quadratic form we need to make some substitutions here, so that here I can just take y equals to n squared. So when you can put y equals n squared, then this nice equation will becomes in the form of y squared. When you put n square equals to y, then it will becomes y square, and here you have n square and it will becomes 4 times of y, and this is 16, and this whole equals to 0. So after substituting this value, this equation will becomes in quadratic form, and now we will easily solve this problem by using the nice quadratic formula. So that here we have a equals 1, b equals to 4, and c equals to 16, and our nice quadratic formula is y equals to minus b plus minus b squared square root minus 4 times of ac, and this whole over 2 times of a. So that here we put all the values of a, b and c in this equation, and you will get here minus 4 plus minus, here you put the value of b and it will becomes 4 square, and it is equals to 16 minus 4 times of a is 1 and c is 16. So 4 times of 16 is 64, and this whole over 2. And now we make some little bit simplifications here, and you will get this equation after some simplification. It is equals to minus 4 plus minus 16 minus 64 equals to minus 48 square root over 2, and we will write it as minus 4 plus minus, here we have the square root 48 equals to 16 times of 3 and its whole square root, and here you have minus 1 square root over 2. So in the next step we will just write here as minus 4 plus minus, you know that the square root of 16 will be equals to 4, and this is the square root of 3, and the square root of minus 1 will becomes iota and whole over 2. And now we will just separate all these terms here, and you will get minus 4 over 2 plus minus 4 into square root 3 over 2 into iota. So this is the value of y. Here we need some more little bit simplifications, and we write y equals to minus 2 plus minus 2 times of square root 3 of iota, because these are cancelled by each other and these are also cancelled by each other. So now we can again make two cases here. I can just separate positive and negative value, and you write y equals minus 2 plus 2 times of square root 3 into iota, and here you have y equals to minus 2 minus 2 times of square root 3 of iota. And now we will back substitute the value of y, because in the start of the problem we will take here y equals n square. So now we put the value of n square here, and you get minus 2 plus 2 times of square root of 3 iota, and here you get n squared equals to minus 2 minus 2 times of square root 3 of iota. And now we will take the just square root on both of the sides in this form, and you will get its other solutions are, because here these are cancelled by each other, and here you get plus minus square root of minus 2 plus 2 times of square root of 3 iota. Similarly, here you obtain n equals to plus minus square root of minus 2 times of square root 3 iota. So these are the two real roots. Similarly, these are the other two real complex roots. These are the two complex, and similarly these are the other two. So here you have total 4 complex roots, and we have only 2 real roots of this problem, and the real roots are n equals minus 2 and plus 2. So these are the our 6 roots of the given problem, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.